Are there any questions? Okay, then I will start asking. So the first question, you mentioned the genetic algorithm. So I remember this. I mean, I remember some papers from some years ago. Here you were mentioning efficiency of your algorithm. You meant the amount of faults or necessary, or amount of computation actually, or?
No, I mean, let's go back to this example. Yeah, just stay with this one. So if I just run the algorithm, it can catch, for example, this 1 point.
Mm-hmm.
Yeah, so this parameter set, which is successful. But in order to ensure that it's not stuck there, I also need some randomness and look at other positions.
Okay.
So this would then translate to the different parameter sets that also can induce a fault. Yeah, so and this is similar to this idea of putting mutation into the genetic algorithm.
Okay, that makes sense. And how your solution compared at the end to the genetic algorithms, or you didn't try to compare it?
So far not directly, so this is still on the to-do list. So in this paper we just want to show if it is it working, what are the drawbacks, what are the next directions to go in. Yeah.
And I have one more question. It's exactly about this slide. Did you try to because like what you mentioned about the spatial case, that makes sense, but did you try to do this in multi-dimensions also?
No, the spatially not. Only
like with respect to other, like.
Wait, no, that's not true. The original setup actually was 5-dimensional, so we replicate the entire setting.
But not including spatial ones.
No, this was for the special ones.
Okay.
So it was position, EM field strength, and white.
Okay, but I assume there was nothing too surprising in this case. I was curious whether there would be some interesting combination, but okay. Thank you very much. Any other questions? Okay.
Have you checked how your approach holds up when there's not a very nice boundary between classes? So if they overlap, for example, if there's a big overlap between brownout is sometimes triggered, sometimes it's not triggered?
Not so far. Actually, that's one of the drawbacks I said before, because it just draws you a borderline. So you do not know the overlapping parts so well. So, I mean, you can model it if you have 3 classes and then you have 2 borderlines, and the area between the 2 borderlines is the overlapping part, more or less.
Yeah, okay.
Okay, any more questions? Okay. Sorry.
Just a quick curiosity. The approach is employed to find boundary regions for fault injection. But another aspect where typically it's a problem to have proper parameters is passive YAM attacks, where you may have location, probe orientation, and the rest. Do you think you can reuse the approach to, say, find the optimal location of the probe with less steps than the usual scan or orientation?
This is actually what I meant on the to-do list with restriction areas. This goes directly in the direction. So what's the smartest way actually to go over to scan the chip? So if you want know one position where the fault was successful, how wide you should go, or how far you should spread out, especially also with the sort of putting this random point into it, in order to avoid that you end up in local minimas. But we haven't done so far. This is on the roadmap. Okay. So from my gut feeling, I would say, or from the data we got observed so far, I think it should be doable, but there's no evidence at the moment.
Okay, thanks.
Thank you very much. It was great, very interesting presentation. Thank you.